So welcome to my dear student. So this will be a very introductory video about the analysis of hydraulic transients. So basically, mainly in thermal power plant, in heat transportation system, mainly we are talking about the fast spectrum reactors, where the coolant is liquid sodium, and this liquid sodium is very hazardous in nature. If it comes the contact with air, so it will cause the exothermic reactions, and eventually the pipelining or any pressure vessel or pressure piping, it will be made of very very hard material, which are brittle in nature, okay, like P91. So it's very hard but brittle, okay. So if there is any occurrence due to heat or due to hydraulic transient, if the stress develop inside the structure is if it crosses the ultimate tensile strength of the structure, then there will be a brittle fracture and the catastrophic failure. So you have to stop all these things. So when we are designing this, there is a thing called leak before break criteria. That means before the brittle fracture or the catastrophic failure take place, it will be initiated through a leak, and slowly that crack or the leak will propagate. And once the leak is initiated, then it will be detected through the detector, and immediately the system will be shut down, or some necessary actions it will be taken, so that the hazardous conditions can be avoided. So when you will be say some pump tripped, suddenly there will be a backflow, even though big pump having some ratchet, or the inertia of the entire rotor dynamics is increased through some flywheel, so that the GD square value is very high, so that it will retard it very slowly, and it will avoid the hammering, hydraulic hammering. Or there is a sudden close, this big flow control valve, if it is closed suddenly, or the relative opening of the valve is changing very frequently, that time also the pressure transient can happen. So if to implement the leak before break criteria, you have to analyze all the possibility of this occurrence of this hydraulic transients. You can do definitely through analytical method, but it will be very difficult to consider all the boundary conditions together and to solve the equation. So today the computational capabilities are very high, and lot of packages are available. So I used to work for my thermal hydraulics analysis, the Wanda and Flownex. Before Flownex, I started to work with Wanda, so I thought we will do these things with Wanda. So basically, one of my student will be there with me to do all these things. His name is Soham Banerjee. He is from Indian Institute of Science and Technology, so where my alma mater was. So today's this is a very introductory short video how to use the Wanda. So this is the things you can open, and this is the this is your interface. So I will use one one reservoir like this, then I will use one pipeline, then I will use one valve, then I will use one tank like search tank or something, whatever you want. So I have placed it, then using the connector I am connecting it. Okay, now I will be giving the values for this. So this is, say the head is 20 meter, and now I am going for the pipeline. Say this is a 300 NB pipe. Okay, and the length, say it is 1 kilometer, and the roughness of the wall, say it is 0.1. I'm just giving some arbitrary value to show this, and this you can define your own valve. Just 1 minute. Okay, so you can define your own valve through the flow coefficient. So now I am defining it as standard flow control butterfly valve, and this pipe diameter I have used 300 NB. So this also I will be giving 300 NB, and the initial is, you can select the discharge, and this I will be initial, so the initial position, so that position I will be use select as discharge, and this I will be use, say 350 meter cube per hour. Okay, then this is the this is the tank or the storage tank or something, if you can tell. So this is the initial head is 10, and the type, so I can select it as a variable, and I can give when the height is 0, so then that the area is, say 10, and when it is the head is 10, say this is 100 or something. Okay, now this node I will define elevation is 20, this also it will be 20, and this node it will be, elevation will be 0. So my model is more or less ready, so I will be saving it. So just I am saving it. Now I will try to run it. This, we are working for the steady state solution, and the solution is run. Now you can check. So this is for that particular flow, your so this is the valve characteristics. You can see. So here all the details, what will be the, what are the things here, you can see that. And to, you see, this is for that valve position, it should be 36.21% opening is required. Now if you can, because as I told, we want to see the pressure or all the hydraulic parameter details during our final analysis. So you can see here, so this is the head, this is the head plot. Okay, this is the head, and if you see the pressure, this is the pressure plot. If you see the velocity, so this is the velocity plot. So all these things you can, this is just one to give you some idea how to use it. So slowly we will learn how to use it for different applications. So this video was made just to give you an idea and what is the interface and how to use it. If you more practice with this, then you can implement so many things in that. Thank you so much. Thanks for your patience.